Hello guys and welcome. I hope that you're well. My name is I play 4K, aka I play 8K, aka I play 16K or UHD King. During this video I'm going to show you Battlefield 3 running in 8K resolution natively on a single Titan RTX video card with the help of two Xeon E5-2699 V3 processors from 2015 that outputting total 72 logical cores. However, for this benchmark I use only 4 cores per CPU and 14 physical cores was disabled on each CPU, and hyper-threading technology was disabled as well. So 4 physical cores, 4 physical threads per CPU, total output 8 physical cores, 8 physical threads. This Xeon E5-2699 V3 workstation is not the gaming rig. It's a workstation designed for 8K resolution video encoding when every single core is utilized, or 3D rendering, 3D animation like 3ds Max, Cinema 4D, or Blender 3D, where every single core utilized at 100%. But you can game on this system, and it's low budget system, good for all-in-one PC, and today I'm going to go ahead and show it to you. So I'm going to show all kind of different presets. I'm going to show you 2 different missions. It's going to be Operation Broken Sword, and it's going to be going hunting, which is the 4th mission. So 2nd mission in Battlefield 3 PC game, and 4th mission going hunting. I'm going to show all kind of different presets, so pretty much this video will underline the Battlefield 3 experience on a Titan RTX video card or 2 Titan RTX video cards in SLI on a Xeon E5-2699 V3 workstation. I'm also going to show you on my gaming rig, but pretty much it's going to be additional 15% to the FPS counter. That's it, 15%, not that much, but it's going to cost much more money. So 8K resolution, 60 Hz. Today I'm recording this video with NVIDIA Shadowplay that is modified to record in 8K resolution native, and my driver is also modified around 16K resolution, and I was the first YouTuber that in November 2021 showed you Battlefield 3 running in 16K resolution natively rendered. Go ahead and check out that video over the UHDking.com or iplay16k.com. But let's go ahead and get going, guys. So I'm going to go ahead and save it. Campaign. Let me cool down the video card a little bit and show you about my specs. So here's the specs. As you can see, the Titan RTX is overclocked by 100 MHz, and the VRAM, which is the video RAM, overclocked by 1000 MHz, additional output 2000 MHz total. So Titan RTX should run above 2000 MHz on the GPU and above 16,000 MHz on the VRAM. But it's going to thermal throttle on GPU, and it's going to clock itself to 1800 megahertz. Okay, this is Titan RTX versus this 2 Xeons E5-2699 V3 that is with disabled cores, just designed for the gaming, for the 8 cores for the particular benchmark. Otherwise they would be faster. Xeon's running 64-bit machine code, and Titan RTX running OpenCL, similar simulation, fastest as possible, close as possible. But as again, Xeon E5-2699 V3, 2 of them 172 logical cores will show much faster FPS. 2 Titan RTX showing double over here, the digits double. Go ahead and watch my 2 Titan RTX in SLI 8K resolution Battlefield 3. As again, I covered every single piece in Battlefield 3, 8K resolution, 16K resolution, and 4K resolution on a Turing GPU architecture such as RTX 2080 Ti video card, or RTX 2080 Ti in SLI, or Titan RTX video card, or Titan RTX video cards in SLI. So as you can see, socket 1, socket 2, 4 cores, 45 megabytes level 3rd cache per CPU shared, so above 11 megabytes per core. Okay, this is how we're running. Main board, Chinese motherboard. I'm going to show you a video tutorial where I'm going to modify this motherboard, which is like a hacking to improve the performance from 20-30% to lock the Titans on the 72 logical cores at 3.4 gigahertz, so we don't have to shut down the cores in the BIOS. Every single core will perform that. Okay, 16 lanes on the PCI Express 3.0. Memory will be 179 gigabytes. CL15 2133 megahertz or 1064 times 2. Quad channel 256 bits, so not dual channel, which is 128 bit, but quad channel, which is 256 bit. Unbelievable output, above 50 gigabytes per second or 15,000 megabytes per second, as you can see here. This is the Titan, single Titan RTX. Secondary Titan RTX is removed from this Mozilla rendering firm version 2.0. This is not Mozilla rendering firm version 2.0++ that came with 2 Titan RTXs. So this is just with a single. I built this system just for you guys. So this is the score versus the 5000 series Extreme Intel Core i7 that's using additional hyper-threading technology on, so additional 8 virtual cores. So pretty much we're going to match it, as you can see. Pretty beautiful multi-thread ratio, almost 8 times on the 8 cores. Great simulation, and pretty much those dual socket processors simulated pretty well like a single processor, as you can see, on latency delay and everything. This is the Titan RTX, the information for those folks who is curious. 4608 CUDA cores, version 6.3. CPU ID, this is the CPU ID, as you can see, 33 multiplier times 100 MHz BCLK frequency, output 3300 MHz or 3.3 gigahertz. And the reason why I'm running 4 core 4 threads per CPU to achieve right here 33 multiplier, otherwise it's going to switch to 28 multiplier and going to go down to 24 multiplier. We don't want to have that in the PC gaming, because PC gaming loves PC gaming PC games love higher frequency as possible per core. Okay, so of course 1 core 2 core on the Xeon E5-2600 series V3 will be 36 multiplier, which is amazing, because on the 2600 V2 series Xeon C5 it was only 1 core 36 multiplier and 2 core 35 multipliers. So if dual socket system, we can achieve 4 cores at 36 multiplier, which is 3.6 gigahertz without any modification of the BIOS on any BIOS, if BIOS allows for you to shut down the cores. This is the technology for the hardware gurus. Go ahead and smash the pause button, study it, but you can see what those CPUs supported. For those people who is curious, most likely you're building this as your workstation or a server, whatever the reason is, or a rendering firm. This is a great system, guys. I'm really in love with this system. One of the best workstations that I ever built. Each CPU in 2015-2016 was like $5,000. Each Xeon E5-2699 V3, it is enterprise CPU designed to work at least 20 years. I purchased it for $125 from a local recycler company in 2020. In the middle of 2020, 2 of them for $250 total, and the motherboard for $110. I'm gonna put the links for you in the video description where you can do the same from great Amazon sellers that I trust. Okay, so this is what's up, guys, about that, and why it's running 2133 megahertz as our DDR4 frequency maximum supported, because QPI clock is 4789. So pretty much each DDR should be clocked at 1067 megahertz times 2, which is 2133 megahertz, which is dual channel, but times 4 will be 4789 megahertz, which is the quad channel. Okay, to be able to achieve quad channel on those dual socket Xeon's E5-2600 V3 and this socket 2011 V3 motherboard C612. Alright, guys, so pretty much I showed you everything what you need to know. Chipset about this motherboard. There is going to be a playlist regarding this. Go ahead and don't miss it. That's it. Let's go ahead and get back into the game. On the background, this is my system, exactly what it is right now. and I'm jumping back into the game, and we're going to go ahead and rock it, guys. So I'm going to start the campaign. As again, I told you, 2 different missions, just to underline it, because I bench it throughout the years, those 2 different missions. So first will be Operation Sword Breaker. Okay, it's not about the gameplay, it's about the benchmark. So I really like this mission. And then it's going to be the 4th mission, which is the going hunting with the airplane. Alright, so this thing right here will be with a static camera and could be used as a benchmark, as well as the airplane scene at the beginning. I really like it, could be used as a benchmark because the static movements and pretty much the FPS, it is what it is, and it's great for the split screens, etc. And this is what I'm going to do when I'm going to underline my experience with this system or with the Titan RTX video cards over the UGDking.com YouTube channel. I'm in love with this system. Check out that GPU utilization 98%. This is exactly how we want to have it. We want to have it utilized 98-99%, which is the amazing GPU utilization, as high as possible, but above 97 is amazing GPU utilization. This is exactly how we want to keep it. So we are utilizing all the CUDA cores, which is total, as you saw, 4608 CUDA cores, which is 128 CUDA cores more than RTX 2080 Ti video card. But RTX 2080 Ti video card is similar video card to Titan RTX, and performance will be just 10% slower than Titan RTX. Keep that in mind. Beautiful FPS. Keep your eye at the right top corner, as again, guys, at that self-explanatory data that updated every second. Beautiful FPS, 60 FPS average, guys. And this is, as again, this is the maximum visuals right now. 8K resolution, maximum visuals presets are at ultra, except the anti-aliasing is off and anti-aliasing post is off and motion blur is off, but ambient occlusion is still on, the 60 FPS average. So pretty much ultra preset without the anti-aliasing, because 8K resolution in Battlefield 3 you don't need to have an anti-aliasing unless you're running above 120-inch screen. Okay. And just because it's recording with the NVIDIA Shadowplay, please add 2-3 FPS to the FPS counter without the recording, that's all. And as I told you, additional 10-15% for the FPS if I'm going to run on my gaming rig, which is the i9-9900K, overclock at 5.3 GHz, and pretty much which almost equal to 12,900K, maybe a hair slower, running at stock. One did 12,900K Intel running stock, which is the gaming CPU in the end of 2021 and in 2022. So maximum you can achieve 15% of the FPS boost. So just add around 7 FPS plus 3 FPS without the Shadowplay recording. So just 10 FPS. So almost 70 FPS on the gaming latest processor by Intel. AMD is much slower. They're lying about their processors. That's why they never test them at 4K resolution and above, because they're shining at 1080p, but at 4K resolution Intel takes the lead somehow, and 8K resolution it shows clearly. Because I compare with the Bang for Buck PC gamer from UK on his Ryzen 5950X with the RTX 3090 in 8K resolution. With this preset, he's below 80 FPS and I'm above 90 FPS in this workstation, and on my gaming rig it's going to be even above 100 FPS in 8K resolution with the 2 Titan RTXs and SLI. So pretty much they lie to us about the AMD performance CPUs, and I'm pretty sure they lie to us about the RTX 3090 comparing to his data, and he's legit. So go ahead and let him know. Hopefully he's also watching this video. Beautiful FPS, by the way. I'm running in windowed mode because this is how I was running it since 4 Titan X Maxwell GPU architecture, and this is how we're gonna bench it. But pretty much Windows 10 professional operating system is all about direct 3D surface, even in Windows, so it's not like Windows XP. So pretty much loss in FPS will be minimum 1-2 FPS when you're running full screen versus the minimum. As you can see, a lot of volumetric particles going on right now, which is consumes a lot of GPU performance and slows down our FPS. As again, FPS will be frames per second, which is important crucial component at the right top corner where data is displayed, but as well as ms, which is the milliseconds delay between each frame are rendered. Between each frame is rendered. So pretty much it's a delay between the hardware and software, which is the CPU, system RAM, GPU, video RAM, motherboard, and then software, which is Windows 10 Professional operating system and DirectX 11 API, because the Battlefield 3 is using DirectX 11 API, and it's supporting SLI, supporting SLI amazingly, which is great. So 60 FPS average. This scene is heavy on particles, and I like to test this scene because right here the particles, volumetric dynamic particles, consumes a lot of GPU computing performance and slow down our FPS. So we're gonna see pretty much the lowest possible scenario for the FPS. That's all, guys. So this is pretty much ultra preset, absolutely amazing. As you can see, user interface is not scalable in Battlefield 3, and this is a big mistake of the developers. You can tell the developers never played the game, never care about the game. You always want to care about the game, and you always want to think about the future as the game developer or software developer. So with the HBO and everything is crazy beautiful. So what I'm gonna do right now, guys, I'm going to show you the ultra preset. The next will be the ultra preset, and it's going to use the 4x MSA and anti-aliasing posted high and motion blur, as you can see. So we're going to decrease in performance, but let's go ahead and check it out. I'm going to cover every single preset. It's probably one of the videos on the YouTube that covers this game on a single Titan RTX and two Xeon E5-2699 V3 CPUs. It's not going to be any other videos, so I don't think, why not, right? Let's go ahead and cover every single preset. So we're gonna cover as much data as possible and create information at all kind of multi angles for you to view it and to analyze it. And I'm providing you the information as software developer, game developer, graphics designer, 3D artist, a gamer, a hardware enthusiast, PC overclocker, as you can see. Okay, ultra preset, 30 FPS. So we cut it the FPS by 2. So Battlefield 3 bites through the anti-aliasing, and Turing GPU architecture pretty much cutting the performance in half in Battlefield 3 PC game. Keep that in mind. So it bites a lot, especially when we're talking in very high resolutions. It doesn't feel like so in 4K resolution on Turing GPU architecture and also on the Pascal GPU architecture, but when we're talking 8K resolution and above, it bites hard, at least on those Xeon E5-2699 V3 CPUs. I'm going to test it on my gaming rig, but I didn't realize that it bites hard in terms of the FPS, just the anti-aliasing, because I believe the Turing GPU architecture maximum what I saw was maximum what I saw consumed at least 30% of the FPS lost when the anti-aliasing is enabled, but it looks like it's 50% actually. But it could be the CPU, guys, so it's nice to test on the gaming rig such as i9-9900K, one of the fastest PCs in the world. In 2020, in February 2020, scored number 14 in 3D Mark Ultra Fire Strike, and Jay-Z, 2 Cents, Linus, and all the Canadians and California dudes were all the way on the bottom, guys. And keep that in mind. I have that video over the HD King for you to study and see. This is the true 8K resolution. Let me show you the zoom for those who doesn't. At the distance, when you're going to run 1080p, it's going to be blurred out. 4K resolution going to show a little bit, but 8K resolution and above showing all the details, and 16K resolution will show the details all the way down that hole when you're going to watch at that right there at the door, the 16K resolution going to show the details. Over here it's blurred out, as you can see already, applying that blurriness kind of. It's not depth of field, it's just the blurriness of the pixels itself coming natively, the depth of field. It's not the depth of field created by the developers. It's just a native depth of field because the limited amount of the pixels at the distance, even in 8K resolution. But 16K resolution will show the details. Keep that in mind. So 30 FPS, so we cut it by half, and it doesn't feel so great. It feels a little bit stuttering because the milliseconds, as I told you, important factor, and at the right top corner by the FPS is above 30 milliseconds, and when the latency delay above 20 milliseconds, this is exactly where stuttering comes. And above 30 milliseconds you can feel the stuttering, and it's already not so comfortable. And about 40 milliseconds it's not comfortable at all, and you feel the stuttering. And everything above 50 milliseconds is not playable. Keep that in mind. But it is benchable, and the purpose of this video is not the gameplay or playability. The purpose of this video is to benchmark, so we're going to see how the technology advanced in the future while testing it against the systems, against different video cards, against different CPUs, GPUs, etc. Beautiful, guys, really loving it. Still above 30 FPS, still playable though, but not so comfortable, but still playable, and latency delay still achievable below 30 milliseconds on an old school CPU from 2015. This is unbelievable. And even in 2015 this was not a gaming CPU, this Xeon E5-2699 V3. Keep that in mind. But it's beautiful, I really like it. And Xeon's E5-2600 series V3 already achieved the accomplishment when the dual socket motherboard almost acting as single core, as single processor in terms of the latency delay. Maybe hair slower, but almost there at the level of the performance. Alright guys, 35 FPS, above 30 FPS while it's recording, so go ahead and add 3 FPS at least when it's not recording. And on the gaming rig i9-9900K, based on the algorithms and formulas that I explained, go ahead and add at least 10%. So I would assume like 42-45 FPS will be average on the gaming rig i9-9900K at 5.3 GHz at this scene with this preset. But it's going to cost you much more money, and the whole system with the CPU, as again, cost me $400 except the video cards and system RAM. Keep that in mind. So alright, so there is dynamic particles going on right here, which is very heavy scene. Okay, and stressing the GPU is again a lot, so it's eating a lot of FPS, bringing a lot of FPS down. So it's nice to see what is the performance. Performance is great. Okay, let's go ahead and switch it, guys. So now I'm going to go ahead and test it with a high preset. So we tested with the ultra preset. Beautiful. Now it's a high preset, still with HBAO, and HBAO consumes also about 15-20% of the performance. I'm about to turn it down in the end of this tests during this level, and well, before we're gonna switch to mission 4, going hunting. So what I'm gonna do now we're going to go ahead and restart the mission. So this is the high preset now, and it's still using a little bit of anti-aliasing post, but the method is not that heavy. Keep that in mind. So the FPS should be much higher than you saw at ultra without the anti-aliasing. Should be amazing. And it's already starting at 53, 52. Very nice, below 20 milliseconds latency, but it's using the anti-aliasing post method at high preset. Keep that in mind in Battlefield 3 PC game. So it's not like ultra without the anti-aliasing. It's kind of the visuals is, but that anti-aliasing consumes a lot of GPU performance, as you can see, and it's lowered our FPS by about 10 FPS. I better play at ultra, of course. And as again, I better play it without the HBAO ambient occlusion, but I'm gonna show it to you guys in a second why. We almost done it. High preset, as you can see. We're about to switch to medium, utilizing almost way above maximum wattage on the Titan RTX because the Titan RTX is overclocked, so it consumes more wattage. But still not heavy thermal throttling. And as again, this Titan RTX is on a liquid metal thermal compound paste by Liquid Grizzly. Keep that in mind. And the temperature is about 3 Celsius, 3-5 Celsius, but at least as minimum 3 Celsius lower than on the original Titan RTX. And I'm still using the dual fan air cooler by NVIDIA. But pretty much this type of overclock is achievable on any Titan RTX, on average Titan RTX video cards, or on RTX 2080 Ti video cards. As again, RTX 2080 Ti video cards will show about 10% lower the performance, as you can see. And Titan RTX takes a boost, especially when you have two of them in SLI, because 128 CUDA cores per each Titan RTX as advantage over the RTX 2080 Ti video card will be doubled when you're using two of them in SLI. So it's going to be 256 CUDA cores, and 256 CUDA cores of the 2-inch GPU architecture is a lot, guys. It's like a low-end video card almost. This is the advantage to Titan RTXs in SLI versus the RTX 2080 Ti and SLI. Keep that in mind. So it's running smooth, guys. Below 20 milliseconds, Battlefield 3 is smooth. Not comfortable with 120 Hertz, guys, but below 10 milliseconds, this is exactly what it's going to be for 120 Hertz, guys. Comfortable below 10 milliseconds. People that plays 200 Hertz screens below 5 milliseconds latency delay is where they're looking at. So not only the FPS, but milliseconds and latency delay is very important and crucial in the formula of the comfortable gameplay. As again, beautiful visuals, really liking it. The Battlefield 3 still looks amazing, especially in 8K resolution. Guys, keep in mind that I'm coming in real time. It's kind of hard to play and coming in real time, but I'm trying to do my best. So don't forget to support me, smash that like button, subscribe. As you can see, I'm a very experienced guy in terms of the IT. I'm an IT professional in a lot of fields, so I'm sharing a lot of great info with you. The details are amazing at high, but I would play it at ultra without the anti-aliasing post with higher FPS and even much better details. We don't need, as again, any anti-aliasing at 8K resolution. So as you can see, the volumetric dynamic particles will go ahead and consume. As you can see, they're dynamic because the direction of the particles by the wind, or it could be nicely done as sprite animation. But anyways, every single particle is a sprite or a color in our case. Okay, below 60 FPS at high because the anti-aliasing post at high. But very comfortable gameplay, and it feels like 60 FPS for sure. It's comfortable. I don't feel any delay, not like at ultra. At ultra 8K resolution, yeah, I felt the delay. It wasn't the comfortable gameplay at all. I felt a little bit like stuttering. I felt like 4 Radeon R9 290s in Crossfire at 4K resolution with that type of stuttering back in 2011 when I tested Battlefield 3. As one of the first YouTuber in 4K resolution. People were saying like nobody needs 4K, people cannot see the 4K, but what about the 8K? Everybody can see the 8K. So pretty much it was the propaganda, guys, on YouTube. And what I advise you to stop watching those type of YouTubers. And there is a lot of YouTubers like a high school kids that are lying about the performance. Over the UHDking.com, if I'm posting the video or benchmark, it's going to be legit, guys, all the time. So we saw the FPS during the volumetric particles. So it's We saw everything which we need to see, as again volumetric particles. Let's go ahead and switch out. It's still about 50 FPS even when it's recording. Of course, if I'm going to run stock my Titan RTX, which is I'm not advising you to do, it's still a great temperature, 70 Celsius. Go ahead and overclock it. You received would overclock additional 10% of the boost in terms of the FPS. So a stock power would be maybe below 50, like 47, 49 on average. So okay, alright, so high preset, we saw it. Let's go ahead and switch to medium and let's go ahead and reboot the game. I'm gonna apply that. Restart the mission. Battlefield 3 doesn't require for you to reboot the game while you switching the preset, and we're Gucci without any reboots. As you saw that pre-rendered animation, it was just not the pre-rendered animation, it was pretty much pre-rendered video, and you cannot bench based on that video. The FPS is 200, it was locked. The maximum FPS supported in Battlefield 3 and Battlefield 4 will be 200 FPS on this Frostbite game engine that is powering Battlefield 3 and newer Frostbite engine powered Battlefield 4, but pretty much Battlefield 4 is about 15% slower than Battlefield 3 and almost with about the same visuals, but there is some improvements in Battlefield 4 and the newer Frostbite game engine. And of course newer Battlefields will be even newer Frostbite game engines, and they're going to be a little bit different stories. I'm going to test the newer Battlefields, including the Battlefield 2142 and 2042, guys, and Battlefield 1 and Battlefield 5 over the UHDking.com on this system. Go ahead and check it out. It's going to be a lot of great videos for you to watch. So medium above 60 FPS. Alright, latency delay for sure below 20 milliseconds, so it's running beautifully, guys. It's running nice and smooth. Feels great without any stuttering. But still below 10 milliseconds, that latency feels so great when it's below 10 milliseconds. But as again, not with this type of FPS and not with this type of technology, which is NVIDIA Turing GPU architecture, and two-way SLI by NVIDIA is not enough for two Titan RTX to run it, guys. 16K resolution at 60 FPS. But go ahead and check out that test, 16K resolution, which is 133 megapixels rendered in real time. As again, I was the first YouTuber. That's why UHD King, because I was the first YouTuber ever with 16K resolution back in 2015. It was Counter-Strike Source, and then Half-Life 2 over this YouTube channel in 2016 in 16K resolution or 133 megapixels rendered in real time. But I was also the first YouTuber that showed you Battlefield 3 in 16K resolution in November 2021. Go ahead and check it out over the UHDking.com or check out the video description. I'm gonna go ahead and put it under the comments for you to click and check it out. About 60 FPS, medium preset. And we're at 70 Celsius, so if we're gonna cool down the Titan RTX, we're gonna be about 75 FPS. Okay, we're above 78 already, above 70 FPS average, but I saw that 62, 66 FPS average. And why it is, I think because the Titan RTX is thermal throttling a little bit. That's why, otherwise we would be at an average at 70. Feels such a smooth. This is a great experience for online multiplayer right now with this type of visuals and with this type of results as they output to us, and running great, guys. Latency FPS is great and it feels so great. So, and visuals are great as well. Medium still in Battlefield 3 in 8K resolution feels like almost like an ultra Battlefield 3 in 4K resolution. Keep that in mind when we're talking in 8K resolution as right now. Especially when we're talking 16K resolution, every single detail will be here. Every single pixels of that textures will be rendered. Because see, like that car right there, that car right there has, let's say, texture 1080p, right? So right now that 3D mesh on the screen is not even 1080p in terms of the pixels. So that means that we are not going to render the full amount of the pixels of that car as a texture. Okay, so pretty much even in 8K resolution, that's an example for those people who doesn't understand, who's kind of tell me, well, the textures are still not 4K resolution. Well, they need to be 4K resolution because you're not going to look at them as the textures on a full screen. Okay, and so 16K resolution will load the whole car even if it's 1080p, and at 16K resolution we're going to deliver that, but not at 8K resolution. So hopefully guys you understood that. I explained it to you as 3D artist, as again as 3D animator, and as plain as possible and as easy language as you can. So even if you're not 3D artist, you probably should understand the meaning and ultimate idea behind the 3D rendering. Alright, so look at this. This is going to be a heavy scene over here right now, and great FPS. Alright, let's go ahead and eliminate some bogeys. Here we go. We got that. Particles right there. Nice. Beautiful. 50, about 50. But medium preset though. Medium preset is not that great, but as again 8K resolution, you can play like this and in multiplayer. Alright guys, let's go ahead and switch it. So what I'm gonna do, I'm going to go ahead and switch the medium now. So we saw the preset, it's like still about 50, but kind of high 50 average as our minimum throughout, let's say in online when there is a lot of volumetric dynamic particles. So low preset, this is how the low preset will be. Let's go ahead and save that, and let's go ahead and execute that. Restart the mission, and before I will let you go and we will switch this mission, I'm going to show you the preset that I would play, okay, with the ultra visuals, with the beautiful visuals, but with the high FPS. And then we're gonna switch the mission to going hunting, which is the mission 4th. Look at that, 130 FPS average. Okay, lower down. Okay, 78 FPS guys on a single Titan RTX, and it makes sense for us, especially if you're going to, it will make sense if you're going to watch my 2 Titan RTXs in SLI video on Battlefield 3 in 8K resolution on this 2 Xeon E5-2699 V3 running 4 core per CPU, because during that type of condition it was like 140, even sometimes 150 FPS. So pretty much 2 Titan RTXs in SLI boosting 2 times almost performance, 1.9 times at least in 8K resolution and above in Battlefield 3 PC game. So, and this is with the new drivers from December 2021. Keep that in mind. FPS will be the same, the utilization will be also the same. So for those naysayers that saying that newer NVIDIA drivers are not going to support SLI, do not believe them. It's all about the RTX 3090 video cards, RTX 3000 video cards, and newer RTX 4000 video cards and newer video cards, because they never be intended to support SLI at all, because they do not support under DirectX 9, DirectX 10, DirectX 11 APIs SLI. They're acting like Titan V, Titan Voltas, and or Quadros video cards by NVIDIA. They're only supporting multi-GPUs under DirectX 12 APIs or under DirectX 11 APIs. Keep that in mind. So it completely makes sense for those video cards, but as you can see, for video cards such as Turing GPU architecture or older video cards such as Pascal, such as Maxwell GPU architecture, SLI is still supported and it's no problem. But as again, it depends to the DirectX API or your rendering API. Above 80 FPS. 90. So pretty much 79-80 FPS average without the recording, about 80 FPS average, and with the latest gaming CPU that will cost you a lot of money for only like 10 FPS boost, but will cost you double of money just for CPU that the whole system costs, that I'm running today. Pretty much you're going to be like around, I would say even 100 or like low 90s FPS average with this setup, with this two Titan RTXs and SLIs. So Titan RTXs and SLI still have a great life, and if you can buy them in the 2023 after the Bitcoining mining will be over for $400, it's going to cost around $400. It's still a great buy, guys, if you into the old school games. Okay, it's going to cost cheap, just like those two Xeons E5-2699 V3, but you need to understand why you need it and apply that knowledge. And during this video you just learn why you need it. If you're old school gamer, let's say if you're playing Battlefield 3 a lot, Battlefield 4 a lot, two Titan RTXs and SLI completely makes sense for you. Or if you're playing games that supporting SLI, games that are supporting SLI, and you saw it on the videos from the legit YouTubers such as UHD King, then you're going to benefit. Otherwise, make sure go ahead and buy yourself RTX 4000 series video card, middle grade. You're going to deliver almost about the same performance as two Titan RTX from a middle grade RTX 4000 series in 2022 by NVIDIA. Try to skip RTX 3000 series. Invest your money towards the RTX 4000 series and do not get the flagship. Go ahead and get yourself a middle grade video card, kind of like in the range of $400, $500, because this is all what you need pretty much. The PC gaming, as you can see, is dead and there is no new innovation, so you will be Gucci with that type of technology in terms of the FPS and everything. So alright guys, volumetric particles, you saw the FPS. I hope you kept your eye at the right top corner during that time. And let's go ahead and do one more thing before I will let you go. So it was the low preset, FPS was so healthy, above 70 FPS. Latency delay was like crazy in milliseconds. So before I will let you go, let me show you how I would play it. So pretty much this is how I would play it. I will turn down everything at ultra, except I'm going to turn down, of course, anti-aliasing post, motion blur, and ambient occlusion. And this is going to increase our FPS. And let me show you what ambient occlusion does for those newcomers. I know there is a newcomers. So pretty much it's like a Photoshop inner shadows. So around the each edge, let's say this is the edge right here, it's going to create a kind of gradient shadow. So it's going to gradient of the gray into the black slowly. Right now it's not so slow, so the shadow is going to be right on the edge right there, but it's going to be create an extra shadows here. Check it out. And on every single object around the 3D meshes, on every single edge. So this is the deal. As you can see, this is how it's creating. So it's creating an additional around every single edge, an additional kind of darkish, grayish kind of effect of, but it's pretty much as a gradient and fakish shadow effect, but it's still fakish. So I think without it, it's still great because it still comes with the shadows. It's just additional kind of shadows, kind of making the shadows softer. This is the technique that is used. So it's not going to be so hard, it's going to be softer, kind of more like a photorealistic thing. Okay, so this is what we're gonna do, guys. This is how I'm gonna apply, and we're gonna test it one more time, and I will let you go to a second mission after that, which is going hunting. Just real quick, we're gonna go through that and we're gonna be done. So we start the level. Let's go ahead and have a look. And of course, guys, I'm gonna do the split screen. It's going to be additional video, short video with the music, when I'm gonna split screen and show Titan RTX versus two Titan RTX and SLI on different kind of systems, and just to underline the two-way SLI technology by NVIDIA over the UHD King in depth. Okay, so Of course, don't forget to smash that like button. Of course, that scene was a video, pre-rendered video, by the way, so you cannot use that video. Alright, so this is how I would play it, guys. Maximum visuals. This is maximum visuals, as you saw, without the fakeish kind of extra softy shadows through the ambient occlusion. And we are 80 FPS over here. So pretty much we're delivering the same performance as at low, almost at a lot of, as you can see, scenes, but the visuals is maximum. And latency delay is still below 20 milliseconds, which is unbelievable. So that HBO ambient occlusion is kind of slow under this Frostbite engine that's powering the Battlefield 3 PC game. This is our conclusion. Software developers, game developers, and 3D artists, as we can see it by watching at the data at the right top corner and watching the whole gameplay as I'm showing it to you as a benchmark. So this is why I'm showing it to you guys. I could split the screen, but this is in depth. This is for folks that looking to have some information in depth, for the extreme hardware overclockers, extreme hardware enthusiasts. Exactly what you're looking for you can find over the UHDking.com YouTube channel. And not only that, as again, the UHDking YouTube channel is designed for the IT professionals. So we're going to speak about all kind of different topics, guys, and every single things will be explained to you in plain English, so with step-by-step tutorials, so everybody will understand. So UHDking YouTube channel is a great YouTube channel for the beginners, and slowly from PC gamers I'm going to convert you guys into the IT professionals as graphic designers, 3D artists, software developers, game developers, and hardware engineers. Beautiful scene. This is how I would play it, guys, and the visuals are on another level, as you can see, above 70 FPS average, and this is on the thermal throttling Titan RTX video card. How to avoid it? You can build yourself a hybrid water cooler by investing $140 by purchasing the bracket, purchasing the H55 water cooler by Corsair on that bracket and a GPU, and pretty much cool down the Titan RTX. And you're gonna bring the temperature to 55 Celsius. It will never thermal throttle, and you will run your frequency above 2000 megahertz stable. And I would assume that you can increase 1-2 FPS maximum. If this works it for you, go ahead and do it. But for me, I think too much. So I like the free overclocking through the software that I applied today, and that's pretty much it. Because it's safe, without any modifications. There's nothing you can break, because while doing those modifications you can damage your hardware. So everything what you do and everything what you see, everything what you're gonna duplicate, and everything what you saw over the UHDking.com, I play 4K, AK I play 8K, AK I play 16K YouTube channel. You're doing it on your own risk and expenses, and nobody will compensate you anything, guys. Please keep that in mind. Beautiful FPS at the maximum visuals. Look at this. This is just unbelievable. The experience on a single Titan RTX video card, even out of this 2015-2016 enterprise workstation CPUs, will be amazing. And this is not the gaming CPUs. Imagine to set it on 5960X, a gaming Core i7 Extreme Intel CPU, and overclock at, let's say, to 4.2 gigahertz, 4.4 gigahertz. You're gonna achieve a great 10% of the FPS boost over here, and you're gonna be at least at 100 FPS on average. Just running this ultra preset, or at least this type of scenarios will be equal to when you're going to run the Core i9900K overclock at 5.3 gigahertz, guys. Even with the 6 cores, not with 8 cores, because as you can see in 8K resolution, 8 cores is more than enough in Battlefield. So if you can run 6 cores but have higher frequency, go ahead and do it, because you're going to benefit more than through the cores, because you're not going to benefit after 6 cores in Battlefield 3 PC game in 8K resolution. You're not, but higher frequency will benefit you for sure. Alright guys, so we saw that still about 50 FPS, so pretty much FPS was almost the same as we were running low, but we didn't run low. We did ultra preset maxed out. This video will be unedited as again, but I'm going to use the FFmpeg application, as I told you, to convert this video into smaller size but same quality, with a huge decaying preset under FFmpeg++ application that you're going to experience very soon, guys, if you're going to use my technology. It's going to be a freeware video encoder, video editor, but pretty basic and simple. So this is the presets. So let's go ahead and start with this type of presets. I'm going to actually right now include the ambient occlusion. We're going to come back now to mission. Let's go ahead and quit this. Exit to menu, to a 4th mission. And real quick, it's going to be a fast benchmark. I know this video will be over 1 hour, so support me visiting my sponsors, guys, ads, watch them, smash that like button, share it with the friends. Everything is covered, and if you bench it before here or there, you can pretty much see the data and compare. It's not going to be that hard. So as you can see, ultra preset, everything maxed out, campaign, replay mission, going hunting, mission number 4. Here we go with the airplane, easy mode. Let's go ahead and check it out. It's going to start with a beautiful benchmark, and this is all what we need, just the beginning of the level with the static camera movements, and it's just running so smooth, guys, below 20 milliseconds. Ultra preset without the anti-aliasing, check it out. HBAO ambient occlusion, beautiful visuals, 8K resolution, single Titan RTX video card, and a single video card, unbelievable. RTX 4000 series flagships, guys. Video cards will show here like cuckoo 120 FPS on a single video card for sure. This is going to be for sure 120 FPS. I think they're going to be like 140 FPS in 8K, 140-150 on the flagship of RTX 4000 in 2022, in April of 2022. But we're going to test it, so support me. So we'll collect those pennies from ads and we'll reinvest back into you guys, because I'm on my pocket and I already invested in this YouTube channel 40,000 United States dollars. It's not that simple, guys. As you're watching it, it's costs a lot of money, time, energy, so I need your support. Look at this, we are above 280 watts. The data is real at the right top corner. Everything was verified. Sometimes, as you can see, when wattage goes to above 20,000 watts, of course it's for half of the second, it's a mistake, but then app is correcting itself. The data is correcting itself by the artificial intelligence. Which is built in any computer. It's so intelligent. Computer already know the left side of the equation, guys, no matter what you're gonna program on the right side, and it should be equal for it to be able to run. Alright guys, beautiful FPS. We just saw absolutely amazing FPS. Let me go ahead and switch it now. So now we're going to go ahead and see the FPS at ultra, and in the end I'm gonna do without the ambient occlusion. So ultra preset completely, 4 times MSAA and anti-aliasing posted high. Beautiful. Let's go ahead and save that. Okay, and zoom out and load the checkpoint. So it's going to be without the video. So about 14,000 megabytes, so pretty much 16 gigabytes or 16,000 megabytes is required for Battlefield 3 to run comfortably without any video RAM overload, without any VRAM overload. Okay, and the system behaves as usual. I'm usually utilizing 11,000 megabytes slash 12,000 megabytes in PC games when I'm playing in 8K resolution in terms of my system RAM. So there is no overload going on, and you're gonna spot the overload real quick. The milliseconds latency delay when VRAM overloading some data into the system RAM, pretty much it goes like from 100 milliseconds all the way to 900 milliseconds when you're using DDR3. This is what we saw under the Xeon E5-2699 V3 version, which is much older than 2600 V3 version that I'm having today, but it's using DDR3. It's so slow. But even DDR4 that I'm using today, when you're gonna see the VRAM overload, it's going to go like this. It's going to go like 69-350, sometimes 490. It's going to be faster latency delay in terms of milliseconds, but still in ways that it's not playable at all when it's going to store some data into the DDR4. So DDR5 can compensate that, because DDR5 will be fast, especially DDR5 at 6000 megahertz will be very fast. And when you're going to overload some data from a VRAM into the DDR5, the scenario could decrease the FPS, and at some point of the scenarios and benchmarks you can run 16K resolution even when you don't have 24 gigabyte of VRAM, let's say. Okay guys, so you saw the average, the latency level was very high though. That's why I like to show you this benchmark as well, because also these ships have a lot of polygons in them, a lot of models, 3D meshes such as airplanes with a lot of polygons, as again a lot of folks over here, characters with a lot of polygons in them as well. So this is pretty much what you're gonna get online when you're gonna play it. This type of polygons on screen rendered in real time about will be right in terms of the polygons count. So alright, so I showed you ultra. Let's go ahead and switch to high. I'm going to show you high. Still going to be with anti-aliasing post at high, but without the any methods though. So let's go ahead and save that and zoom out and load the checkpoint. So high preset. And Titan RTX, as you can see, thermal throttling, but not that bad. So it's still at a high frequency. So pretty much it's running right now with the overclock, just like it's running without the overclock on stock frequencies when it's not thermal throttling. So that's why I decided to overclock it, but pretty much it didn't help me that much. It's going to help me only when the frequency on the GPU on the Titan RTX will be above 2000 megahertz. But frequency on the VRAM is not downclocking itself, so it's still at 16,000 megahertz, so additional 2,000 megahertz boost. So pretty much our overclock on GDDR6 Samsung on this Titan RTX, which is 2,000 megahertz additional boost through the free overclock, is equal to our DDR4 frequency, memory frequency, because it's 2,133 megahertz that I'm having today over 178 gigabytes installed as system RAM in this system. So we have more than enough system RAM to offload any type of data, as well as I can use it as a RAM disk, but as I don't see any advantages to use a system RAM DDR4 as a RAM disk, because Crucial MX500 SSD is fast enough for anything in my case, except maybe to load some crazy games, but as again to do anything as a professional, IT professional, because even 8K resolution at 60 FPS recorded with NVIDIA ShadowPlay that I'm recording right now is pretty much not even going to utilize 100 megabyte per second data transfer. Keep that in mind. So a Crucial MX500 will be more than enough. So I don't see any scenario. Maybe when you're running server and a lot of people accessing it, or accessing it as fast as possible, then you want to have the RAM disk and allocate about 100 gigabytes as storage. So it's going to be faster ever storage in 2021/2022, even if you're using DDR4 as your storage, because it's going to be faster than any SATA 6 Crucial MX500 that I'm having today. It's going to be data going to be like 4,000 megabytes per second data transfer. It's just like nothing can match in 2021 that, except you're running the DDR storage itself, RAM disk storage. Alright guys, so I showed you, so only that type of scenario will be Gucci for that type of activity. So graphic quality at high, so let me go ahead and switch it to medium now, because you always, when you're comparing, you want to keep your field of view at 90 because you're rendering more information. So when you're keeping at 70, your FPS will be a little bit higher. Keep that in mind. So medium preset, save that, apply that, zoom out, and load checkpoint. Let's go ahead and load the checkpoint again. FPS average, but as again, it's starting with kind of low polygons count and effects, not too much as you can see, but then we're increasing that. We have some particles was flying in the air as you saw it. It could be though a sprite, and I think this is a sprite and they're not flying, we're just walking. And we have post-processing filter on our screen, those kind of dusty on the glasses. So when those two combine, it's kind of creating that effect of animation. But it could be not a sprite, but could be a particles. But in the end, it's going to be a sprite or particles as a color, not as a texture. Beautiful GPU utilization, CPU utilization below 50%. So pretty much 4 core, 4 threads will be more than enough here. Maybe at few seconds you're going to overload 4 core, 4 thread with bottlenecking and reduce your FPS maybe at few seconds, sometimes milliseconds, but as you can see, not always. So pretty much 4 core 4 threads will be enough in 8K resolution. For sure it will be enough in 16K resolution, because the higher resolution, the low cores you're using. But if you want to increase the FPS in 3D games, then you want to increase the frequency per each core and instruction per core. Both of those value and variables in this algorithm is very important when you're increasing the FPS in 3D games and PC games or any games based on latest 3D rendering APIs. Alright guys, so we saw that. So let's go ahead and switch now to low, and after that I'm going to show you ultra preset how I would play it, and I'm going to underline it with the hardware specifications. And actually I already showed you the hardware specifications, so we're going to just end up this video, but check out the video description and video comments for more great videos from me. So as you saw guys, we are at low now. Let's go ahead and load the checkpoint. I'm gonna click OK. Can we achieve like 80, 90 FPS? Yep, we can. Even on an old school Xeon E5-2699 workstation CPUs, no problem. But as again, what makes this CPUs as workstations, because they were running low frequencies per each core, and they had a lot of CPU cores. And games during that time in 2015, 2016 did not utilize more than 4 cores, as you can see. And the Battlefield 3 was the most advanced game during the 2015-2016 or Crysis 3. And pretty much the games require the higher frequency per core, and 2.4 gigahertz as each Xeon E5-2699 V3 with 18 physical cores and 36 logical threads or logical cores are not enough, because you have the advantage of cores that you're not utilizing in 3D games, and you have disadvantage in low frequency. So that's why it's workstation CPU, but it's fixable by applying some methods and techniques and strategies to convert this CPU into the gaming CPU when you need it. And how to do it? Pretty simple. Disable 14 physical cores and hyper-threading technology in the BIOS. Run 4 cores. If you have 2 Xeons E5-2699 in your workstation, so it's going to be double as 8 cores, and you're going to be Gucci at 3.3 gigahertz per each core. and boosted from 2.4 almost by 1 gigahertz additional, you're receiving over here at least 1-2 FPS additional boost, okay, to start with. And yeah, so this is how we converted the workstation real quick with some strategies and intellectual approaches into the gaming rig by utilizing oral knowledge and to max out the FPS. This is the strategy that I showed you guys, how to use this all-in-one system everywhere, and what kind of strategies you need to apply. Pretty simple, self-explanatory. Alright, so low, we saw the low, now it's going to be ultra again. It's going to be ultra, and this is how I'm going to play it, guys. 8K resolution. So disable the anti-aliasing deferred, disable the anti-aliasing post, and disable motion blur, and disable the ambient occlusion. As you already know, you know what it does. Let me show it to you what it does. Pretty much creating the gradient, pretty much softening the shadows on the edges of the 3D meshes. This is what it equals to. So this is how I would do it, guys, and let me go ahead and save it, and this is how we're gonna run it now. I'm gonna go to checkpoint and the last test. So this type of scenario gave us throughout the mission, second mission, the highest possible FPS, and it does right now, about 90 FPS. Wow, check it out, because we're utilizing at ultra presets the GPU as much as we could, and we utilizing less of CPU, so we're cutting on that CPU and we're utilizing the Titan more, especially at that 8K resolution. And so pretty much we not receiving that disadvantage of our slow instruction per core on our CPU, because we limited our calls to CPU as much as possible. We're not calling it at all almost in 8K resolution and above, but we're utilizing our GPU as much as possible, as you can see as well, based on that wattage at the right top corner and GPU utilization. Beautiful, guys. As you can see, maximum presets, we're never even going to see 45%. Oh, I just saw 48 for half of the second, but never 50%. And this is 8K resolution. That means that 16K resolution is going to be less CPU cores utilization, more GPU utilization. GPU utilization will be like crazy under 16K resolution. You're gonna squeeze every single drop out of the Xeon, out of the Turing GPU architecture that inside of our Titan RTX video card, or similar as again GPUs under the RTX 2080 Ti. So RTX 2080 Ti, 10% slower, keep that in mind, but pretty much the same deal. Alright, guys, that's it. I think we're done here, guys. Hopefully you enjoyed this video, and I enjoyed it so much. And don't forget to smash that like button, subscribe, support me, share it with the friends. A lot of time, money, energy was invested, and I gotta go. Look like a phone is calling, so I took my attention to it. And I will see you guys in the next videos. Stay well, stay smart, and support. Till the next time. I play 4K, aka I play 8K, aka I play 16K, or UHD King, and you know now why UHD King. Laters, alligators.